Neeraj, CTO and co-founder of Bluzelle, and welcome to Gitcoin Hackathon number 10. We're going to be introducing the public to our technologies and the various hacks that we are providing bounties for. We're going to walk you through the following outline. The first thing we're going to do is we're going to show you how to set up a fresh new machine, a Unix machine, a Linux machine more specifically, set up our stack, and give you the ability to run a simple console application that uses our CRUD, or as in create, read, update, delete, decentralized database. Briefly, we are using Cosmos technology. It's a blockchain, and our services include a key value store. We also provide Oracle and NFT services. We are also building support towards the EVM, or the Ethereum virtual machine, in Polkadot, and some of our bounties will actually reflect an aggressive approach to improve our ecosystem and value proposition. While our hacks all have a start and end date as is stipulated by Gitcoin, we are okay with work continuing after the hackathon so that winners can finish the projects as per our standards if they require additional time. So without further ado, I will hand the microphone and screen over to Evan, and he will introduce us to the onboarding process and show us how to build a console application using the Bluzelle database. Evan.
Yes, hi, I will start by sharing my screen. And like Neeraj had said, we'll start by getting our machine up to date and ready to go. Now, I will refer to a documentation in order for this process to be as clear as possible. We'll let this thing get going. I think the share has stopped. 1 second. I don't. Okay. Sorry, I don't think this screen sharing is working. Okay, I think I have the screen shared now. So starting on a fresh machine, we're just going to get everything ready to go, and that first off having the correct version of Node. So I'm going to refer to our documentation and just to follow these steps if we're having a fresh computer. So I'm just going to copy and paste our commands here. Shell and install 14. And use 14. So now we should have our correct version of Node, and that should be ready to go. Excuse me. So now that we're ready to go, the first thing we want to do is start a project. Now, I already have a project set up, so what I'm going to do is just clone my repository from Git. Okay. Okay, so I'm going to navigate to an example of a project using the new SDK. The CRUD demo. Okay, so the first thing is we would like to install Bluzelle.js. Now, if you're using Yarn, you can say yarn add at Bluzelle/SDKJS or npm install at Bluzelle SDKJS. Now I can demonstrate that, but I have it in the package.json, so I'm just going to install all the dependencies I have, and I'll show the Bluzelle.js in the package.json of this project. You'll notice the latest is 1.1.2, and that's all you need. Once you have that installed for your project, you'll be able to interact with our chain using this SDK. So the first steps, if you are participating on testnet private, is to obtain a funded account. To do this, again, in the documentation, this is laid out, and I'll follow these steps one by one. The first thing is we're going to want to mint an account. Now, this is an endpoint that will provide us with a mnemonic and an address, and provide us tokens, test tokens to use on testnet private. So I'm just going to go ahead and navigate there. And it's going to take a couple seconds to load up. So I'm going to give that a little bit of time. And there we go. So right now it has just come back as an address and a mnemonic. Now, the first thing we want to do is make sure we save this mnemonic. We don't want that disappearing on us. So I'll keep that on the side here. Now, the second thing is we want to make sure that our tokens have been deposited correctly and minted properly. So second thing we can do is hit that endpoint in step 2, which is to check the balance of our account. So again, navigating to that endpoint and pasting in our Bluzelle address, we're going to check to make sure we have tokens. And as you can see, we have sufficient tokens in order to be able to use this account. So this now validates that, hey, we have some tokens in our account. This is a good mnemonic. Let's use it. So I'm going to go ahead and grab this mnemonic. And now that's everything I should need in order to start using the SDK. So looking at the structure of the project here, it's a very simple console app. So consisting of one source file. This is all in TypeScript. And I'm just going to go dive into the code a bit and get set up, with the SDK. So I'm going to navigate down to the main function here that we'll be using. And these are all helpers, and I thought we can just go over the usage and maybe see some examples of using the SDK. So the only thing you need after installing the SDK is using the constructor Bluzelle. This is going to return a promise of the Bluzelle SDK. And this will provide you an instance of the SDK to be able to use. Notice I'm using async await in this case. Now, what I want to do first is I want my instance according to my minted mnemonic that I had just grabbed. So I'm going to just remove these fields and fill them in again, and we'll go from there. So the first thing is the mnemonic. I'm going to pass this in as a string, and I'm just going to copy and paste that mnemonic that I got from the mint endpoint, followed by the URL, which is basically the node we want to connect to on testnet private. In this case, you'll want to fill in the sentry, client.sentry.testnet.private.bluzelle.com at port 26657. And that'll connect you to testnet private. The last two fields to go over are max gas and gas price. Now, max gas is going to be a parameter that's passed along with any transactions you send with the SDK. Like any transaction on the blockchain is going to require gas, and it's going to cost some money. So these two parameters, max gas and gas price, are ways of configuring how we want to send transactions. So max gas in this case is, I think, 100 million or something like that. And that is going to say, hey, don't consume over this amount of gas for a given transaction. On the other side, gas price is the number of UBNT per gas you were willing to pay for your any transactions. In this case, 0.002 UBNT. UBNT is the denomination of the native token in 10 to the -6 or something like that. Now, if the gas price is too low, a transaction could be rejected by the network. Say the validator's gas price is greater than what you input here. So what I have right now is sufficient in order to allow transactions to be processed. So I recommend that when you fill in your SDK, you can use those parameters, which again are in the documentation. You can just copy and paste it. So yeah, so once you've done that, you have a client that is able to connect to testnet private. Great. Now, what are we going to do with it? So in this demo, what I'm doing is just doing a bunch of CRUD methods in just, top to bottom and messing around with it a little bit. But I will go over the usage, the hierarchical usage of the SDK in order to be able to use the modules and methods that are attached to this SDK. You'll notice that the syntax here, SDK again is the instance of my client, followed by the module I'd like to use. You'll have access to modules including CRUD, which in this case is DB. There's NFT, and there's also some Cosmos modules baked in, also available from banking to staking. But right now we're focusing on CRUD. So the module you'll be using is DB, followed by the type of transaction, query, or field. Now, in this case, since I'm doing a transaction method, I am prefixing, again, TX, denoting a transaction, followed by a transaction method. Now, the documentation will provide a full list of available transaction CRUD methods that will be available. In this case, I am doing a create. Thanks to the way we built this with protobuf, each method is going to take a object, in this case, a message create request. And notice that each of these parameters are just baked into one object that we're passing to this method. And to just go over one as an example, creator is actually going to be consistent across all transaction methods, because we're signing a transaction. You need the creator to be matching the person sending it. And this would be your Bluzelle address. Now, thankfully, I don't have to copy and paste the Bluzelle address I got from the endpoint. The SDK actually holds the address for me. So if you say sdk.db, and now you have access to certain fields, one of those fields is your Bluzelle address. So whenever you decide to do a TX, you can just put in sdk.db.address, and that'll work out for you. And some specifics to the function, we provide the UUID, which is our namespace, your namespace in the database that you want to create a key value in. In this instance, I'm using the current time and date as a string value. Next is the key, which is the key that I'd like to create, followed by the value. Now that protobuf has generated these request types, and in TypeScript it'll show you the types that it's expecting, and value is always stored as a byte array. So you'll notice here that I'm having to encode value my value in order for this to work. So whenever you want to store value, maybe you'll get a value back, you're going to have to do some encoding in order to get a string human readable value back. Last is metadata, which is just another UID array. You can put whatever you want in there. And the lease. Now, the lease is important to how CRUD works, because that is dictating the lifespan of the key value you were creating. Notice this is not optional, and you want to provide the lifespan in, I mean, the calculation will be done for you here, but you could specify the days, the seconds, years, hours, and minutes as integers. In this case, I'm saving it as 1 hour. And that's it. You can refer to the documentation in order to see each and one of these fields, their types, what they're supposed to do. But there's an example of doing a TX. You'll notice that I'm printing out, that I've created it. If no error is thrown, you can assume that the value has been created. And the response object, the message create response, that's supposed to come to be returned by this method, is an empty object. And in fact, all the TX methods will be returning empty objects. So that covers our CRUD transaction creates, and we'll see more of them later on. You'll see that in this example, I'm creating and then reading right after. Now that read is actually not a transaction, it's a query. So you'll notice that we say sdk.db, again, the CRUD module, .q, which is going to bring us to any query methods, followed by the method we want to do. And again, there's going to be a full list of query methods that will be available for you to use baked into the SDK. You might notice that there actually is no creator field associated with the request object that I'm passing to it. And that's just because it's query. We're not really signing anything. We just want to do a query. So here I'm going to read from that UUID that I just created in, and I'd like to read my key. So when I run this program, you're going to see that, hey, I'm able to read that value back. Notice that the response is going to be an object, a query read response. And that will also be an object with certain fields. In this case, query read response will have a value field, which again is going to be a byte array. Because if you remember, we're storing our values as byte arrays. So you can see here, I'm going to have to decode that response.value in order to get a human readable string. So yeah, so if we want to be able to read from our chain, we'll use queries. If we want to commit data, make updates, etc., we'll use our transaction methods. Now I thought I would go down and you could see some of the other methods that are being called. Notice tx update, which will, again, as the name suffices, it's just going to update a value. And if you read it again, the value will be updated. Some other things, you don't just have to read the value. You can also read the current lease of a certain key value. Get lease, for instance, q.getLease will provide the remaining lease time in seconds. And again, as a reminder, it's going to be returning an object. So you can't just respond with, hey, get lease, now it's going to give me seconds. No, it'll give you that that response object, and then you can access the remaining seconds by .seconds, which is consistent. Again, you're always going to be returning an object. So get lease. Hey, that's going to give you the remaining lease time in seconds. Querying key values will provide you with all the key values in the specified UUID, and you'll be able to read that. And the rest of this, again, will be, I'll go through once I run this program. But you'll notice that, again, all of these queries, transactions for CRUD, these methods will be available to you in documentation, especially since a lot of the parameters, there's a lot of them. So you'll want to take a look at that. So that should settle us. Again, just to reiterate, we were able to do all these methods after we've initialized our SDK with that minted mnemonic and URL. And as a side note, as a special thing with us is we get to wrap our messages in the transaction with a very nifty method called with transaction. Now this is just a helper method that I'll be calling later, but if you take your SDK, take the CRUD module, and instead of Q, instead of TX, you can call with transaction, which is actually going to wrap whatever you put inside this function. Again, you're passing with transaction the function, everything you decide to do in there. So here, I'm actually able to send 3 create messages wrapped in one transaction. So that's a particular use that is available as well. So yeah, that about covers a little bit of the code, and I think that settles us so we can try running this thing. So I'm going to get out of here. If there's any questions, please stop me. Let's see. Okay, so we should be ready to go, and I'm going to run this demo. So what's going to happen is, oh, hold on, what did I do? Max gas. Let's see, maybe I just put something wrong in there. CD source. Yes. Maybe I just forgot a comma is my guess. Yeah, I did. 1 second, I apologize. That is a missing comma after the URL. All right, let's try that again. Okay. Yep. There she is. So we're going to start the CRUD demo, and it's going to be printing out logs, and I think I'll just walk through what's happening here. So we start by creating a key, my key, in my value in this UUID, which again is the current date. And if I read that key, my key, it's going to come back with my value, which I've, again, decoded. If I decide to update that key, my key, to updated value for a 1-minute lease, if I read my key, it's going to come back and say updated value. Notice that if I get the lease time is actually at 55 seconds, which is expected. We just reset it to 1 minute for that 1 minute for that lease. Here's me creating 3 new values. So if I decide to call q.key values, reading all the values in the UUID, you'll notice that there's 4 sets in here. The 3 keys that are created, first key, second key, and third key, followed by, or my key, I guess, is just from the very beginning that's in there. And you'll see there's our byte array of the value that has not been decoded. Now here I'm going to demonstrate some of the economics behind our creates. It's not for free, but we will be charging according to the size of the transaction and also the length of time it's being stored. So you notice if I decide to store a key, some key A, and value some value, it's going to cost 369 UBNT or something like that. Now, if I decide to create a key, some key B, same size as some key A, same value, same lease time, it's the same price. So and this is barring that the gas prices change and fluctuate, but they're going to be around the same. In this case, they are. To demonstrate if I decide to create a lease for a short while versus creating a key with a super long lease, you'll notice that the difference between a 1 day and a 1 hour create is going to be like 6,000 tokens, 6,306. So you're paying for what you get for what you're paying for, I guess. It's a way to say it. To demonstrate another query, here's q.search. I'm going to search all my keys that start with the letter S, or my search string is S, and it'll walk the tree and look for all my key values that match that pattern. And all my keys and values that start with S have come up. I can also look for my 5 shortest leases and say, hey, you know what? I want to make sure I don't lose any data, because if I hadn't mentioned this, the reason why we have leases is because when your lease time is up, we're going to be checking every block to see if, hey, is this lease over? Is this lease over? If it is, your key value will be removed from the database. So if I'm querying for the 5 shortest leases in this UUID, you'll notice this is well ordered, 27, etc., from the one that's going to expire the first all the way to the latest, up to five key values. Now what I did next is said, hey, what if I renewed all of them, which is actually another method, tx.renew leases all, which is going to blanket renew every single lease in a certain UUID. And it's not really renew. I set it for 10 seconds. I made it shorter. because if I make it shorter to 10 seconds and I decide to query for the 6 shortest leases, you'll see that the lease time is actually updated. 5 seconds have passed, they're about to expire. So I'm going to, in my demo, I've decided to delay a little bit, and I decide to query all the key values in that UUID, and you'll notice it's empty because all the values have expired. So yeah, so that's just a quick rundown of using some of the CRUD functionality using the SDK. And you can whip up any project you like. I use TypeScript in this case to be able to interact with the SDK. And I think that that about covers it.
Okay.
Yeah.
Okay. Thank you, Avon. That was incredibly thorough, and I'm pretty sure the audience is going to really benefit from that. Does Matthew and Harjot have any questions?
Yeah, I have one. Thanks for the demo, Avon. That was really insightful.
No problem.
I do have a question. So in going back to your code, so with the CRUD methods that you've kind of showcased, I noticed that each one of them have different types of parameters. Are all of them required, or are any of them optional? As in, can I leave out lease in the update or create methods?
Oh, that's a great question. Yeah, so yes, these are going to be very strict parameters, and that's because of our type definitions. The proto files have mapped out each message create, and it has a request and response. And those, when I decide to compile those proto files to TypeScript, those are going to be exactly the parameters it's expecting in that request object. Now, if you're in TypeScript, you might notice that lease is actually optional, but it is required. There is no default lease. You'll have to specify that in order to create your value or update or upsert. But to answer your question, basically, no. These, if you look in the documentation, they'll outline exactly what to pass. With the exception of queries, if you'd like to paginate, say, your response, if I have a bunch, over 100 key values in a certain UUID, and I query that UUID to give me back all the key values, I can specify pagination options, which would be for the request a start key followed by a limit for the number of responses I should get back. So that's also at your disposal and optional. But other than that, they should all be required. Yeah.
Perfect. Thank you.
All right. Great. So we will move on to part 2 of 3, which is going to be shorter. And this is where Matthew will come on and he will demo the to-do application. So Matthew, please go ahead.
Yep, sure thing. Give me 1 second here. Okay, let me know once you guys see my screen.
We can.
Okay, perfect. So, yeah, so as Neeraj said, I'm Matthew. I'm here to basically showcase kind of like a real world application that you can use with Bluzelle, or using Bluzelle, I should say. Specifically the CRUD functionality that Avon had just showcased. So what Avon showcased was, great in terms of, trying to figure out what each method in, the database does and how you can apply it to your application. But this is kind of more of like a real world scenario kind of thing. It's a very simple app. It's a to-do list app. So for those that don't know what a to-do list is, it's a pretty simple concept. You just add items to this list and, while you're adding items to this list, of course, you're creating some sort of commit to some sort of data store in the back. And then you can also mark them as done as you complete them, hence, being a to-do list, which then initiates an update towards your data store for that record. And then you also have the option of deleting that record off your list so that, once you're done, you might want to see it as done, but eventually you don't want your list to build up. So you'd want to delete your items. So that's kind of the real world scenario example here that I'm about to kind of demo. And yeah, so let's get to it, I guess. I'm going to dive into the code just kind of quickly on a high level. So most of the stuff that Avin had talked about already went in depth into the CRUD functionality and all of that stuff. So assuming that you guys have been following, the first step would have been to kind of go to npm if you're using JavaScript or TypeScript, I should say, and go through the installation, create your address using the Mint endpoint over here, and setting up your client. So going back to my code, you can see that I've kind of imported that in. I believe I have the same version as what Avin had in his demo, which is 1.1.2. And this is kind of the file. So this is separated from all the UI components that I have for the app. But basically, this is the CRUD functionality that we will be kind of seeing here. So I've kind of named the functions over here, and I also added some comments as well. So this one actually initializes that client that Avin had mentioned that you needed to do first. The params here are actually taken from here. So like I said, I've hit that Mint endpoint in the beginning as kind of like a requirement for all of this. And then I got my mnemonic there, which is, is essentially it translates to a Bluzelle address, which is funded by that minter. I have my endpoint there pointing at testnet private, and I have my max gas and gas price set for my client. You can also see down here that I've kind of created this user config, and you'll see here that I've set my UUID to do app UUID. So this is kind of that namespace that Avin was talking about in his demo. And yeah, I would keep note of this because we will see this later on once we verify that the create and update and delete messages are going through the chain. So keep in mind that the UUID is set to to-do-app-UUID, okay? So just gonna go through this quickly for the functions in the app. So I have a function here called store to do. And if we take a peek into that, basically it's pretty simple. I'm taking, the time and recording that in a variable. And then I'm putting it kind of in a JSON format here. And then I'm calling the create transaction of the client. So if you remember here, BZ is the client I'm initiating, and I'm just calling the create method off of that with the given parameters over here. So as Avin mentioned in his demo, you'll have the SDK DB address set to the creator, so it's consistent for all transactions. And you have the user config UUID that I had mentioned over here. So keep in mind it's to do app UUID. And then you also have the key and the value. So key being the time that we've recorded down, and then the value being that JSON format that I am saving. So the JSON format includes this Boolean called done equals false. So since we're creating this item, we're initializing it to false, so it's not done. You're adding this with the notion of it's still pending to do. and then you have synced equals false, and then you also have the time which you've recorded, and then the to-do item which you'll be recording in the UI. So you have your parameters there, and then that should be able to send a create to the database. I'm going to pause there. Any questions so far regarding the create method over here?
None for me.
Okay. All right. So moving along. Of course, the R in CRUD stands for read. We'll need some sort of read functionality in this app. And when read triggers, that's basically when the UI is rendering. You'd be able to see your items in your list. And also, if you do things like a create or update, you want it to show up on your UI, obviously. So it would call this load to-dos every time. And that load to-dos is basically, again, referencing the client, the Bluzelle client that we've initialized. And all it's doing is doing a query, which is Q. If you guys notice that create is a transaction because it's changing state in the Bluzelle chain, whereas to read, it's just a read. There's no state change or anything like that. So it's a query. And the only thing you're passing in would be the UUID, which we already know from our configuration over here. So what this does is it'll actually return all the key value pairings under that namespace that we've specified in our config, sorry. And then once we have that listing, we just list them out. And then this is what basically renders into the UI. So that is read there. Any questions on that?
Looks pretty straightforward.
Yep. And then we have our delete. Actually, let's do delete and update at the same time. So basically, the update functionality is in a to-do list is you mark it as done, but you want to keep it on your list. So you're basically just saying that, hey, I want to tell myself that it is a task that is on my to-do list, but I want to mark it as done. And I want to commit that into my data store, in this case, the Bluzelle database. So the only thing I'm doing over here is I'm updating the timestamp on it, but also I am updating that done property within the JSON. So if you guys remember in the create, I'm storing a done kind of property here, which I've initialized to false, signifying that it's a to-do item that's not completed yet. But once I've marked it as completed, it'll set this over to true, and then it'll actually commit that information to the database using the upsert method of the Bluzelle client. So again, I'm referencing the client over there, and it is going to be a transaction since it's changing the state on the chain. And upsert, for those that don't know, will basically update or create a record depending on if it exists already in the data store. So very simple method over here. So it just updates that record that's currently on the chain, assuming that we've already created that. So that's the update. And then just quickly jumping over here for the delete, pretty self-explanatory. Again, it's referencing the Bluzelle client there. And then all I'm doing is creating that delete all, which pretty much deletes all the key value pairing under the namespace UUID that we're using over here. Again, this is a transaction because it's changing state on the chain, and therefore it needs to be a transaction rather than a query. So those are all the CRUD functionality that this simple to-do list app contains. Before we start looking into the functionality in the UI, any questions so far?
None for me.
All right, perfect. So jumping ahead to the good stuff. So again, this is a simple UI here, simple functionality. We've walked through the CRUD functionality of this app. Now we want to see it in action. couple of things to note. What I've opened here as a tab is the Big Dipper. So basically, Big Dipper is kind of this blockchain explorer that lets you view transactions coming into specifically the Bluzelle chain. So if you go under transactions, we should be seeing transactions come in here. And what I mean by transactions are messages or actions, in this case, all the CRUD functionality. So create, read doesn't make a change to the state on the chain. So we wouldn't see that here, but we would see create, update, and delete. As you can probably see, if you guys remember, Avon ran his program and it created a bunch of transactions. The last transaction on his program is probably calling this message renew lease all. So I'm assuming that was a method that Avon put on his program that renews the leases of the key value parent. So that is the last record there. So technically, when we go through this app and go through all the CRUD functionalities, we should be able to see new transactions pop up here from our app. So why don't we go ahead and do that? So let me put in an item here in my to-do list. Add to do, and then it does some UI fun in here and wait for that to load. And then now it's finished loading. So I have my item on my list. Now I'm curious to see if that actually saved in the database and committed that message on the chain. So I'm going to switch back to Big Dipper over here. I'm going to reload this. I should also probably note that I'm pointing this app to testnet private. If you didn't catch it, this is my configuration. So testnet private right here. And we have the Big Dipper pointing to testnet private as well. So just make sure that you're on the correct chain for that. Yeah, so here you go. So as you can see, the new transaction came through the chain. You'll see here that the UUID that we've configured to was the to-do app UUID. Here's the key. As I said, I'm recording the time of when the transaction happened in the app. And here's the value. So if you remember from Avon's showcasing demo, it's actually encoded as base64 strings. So now if we really want to figure out what the value of this in kind of like a human readable format, we need to decode it. So luckily, I have this tab already open here to decode that value. So let's just take away those quotes here. Whoops. All right, we've set to decode, hit submit, and you can see here that it's a stringified JSON object. So the body is actually showing the item that I've committed and the time there. And also done is false as we expected because we've just created this item. So it hasn't been completed off of our to-do list yet. So why don't we go ahead and complete that? So let's go back to the tab, hit this little check mark here that I put in there. You can see that it does some UI fun as well, and then scratches off that item. That tells me that I've finished that to-do from my list. And then it's finished. So it's now committed to the chain. And if I go back to Big Dipper, I will go ahead and reload this. And we should see an upsert once it commits to the chain. Sometimes Big Dipper has a little bit of a delay as well, but it should be up fairly soon. There you go. So, going back to the code, like we said, when we're toggling that done property, we're hitting the upsert method for the client. And once that executes, then you can see that the message is sent on the chain. And to prove that it's actually updated, let's hit this value. So right there, the UUID is to do app UUID, same thing. This would have changed. And actually, sorry, let me back up. The key wouldn't be changed, but the value would be changed. We expect it to be changed. So let me decode that quickly here. Then we hit submit. And then you can see here that the done property is now true. So now we know that with this item, using this key, it actually updated the value using upsert. So it modified that key value pairing, specifically the value on the database, and marked it as true. So now my app can actually read and say, hey, this record is actually done, do this kind of update. So there's the scratch. And say, I end up having a lot of items that I'm pretty much done with, and I don't want too much cluster in my to-do list. All I need to do is hit delete. And then I should expect the items to disappear from my list. And of course, I want that deleted from my data store as well. So now that that's deleted, I'm going to check back into the chain, reload that, and we should see a message delete pop up. And let's do a reload there. And there you go. So I'm calling the delete all there. To verify that, if we look into the delete to do, you can see that I'm calling the delete all method there from the Bluzelle client over there. And yeah, that pretty much concludes my demo over here. So we've kind of walked through, just to reiterate, we've kind of walked through doing the create in this app by entering a to-do item in here. It popped up here, which means that it's doing a read against the database. And then we've also done an update where we've toggled the item's done property. So I've marked it as done. And we've also deleted the item, which we've all seen here in Big Dipper, showing the different transactions. Any questions on all of that?
I don't have any. That's pretty comprehensive, Matthew.
Yeah, that looks great, Matt.
Perfect. Okay, and that concludes the demo here.
All right, thank you, Matthew. All right, thank you, Matthew. So without further ado, here is part 3 of our workshop. We're going to walk through our 8 bounties. I know it lists out 12 bounties here, but we're only going to talk through the 8 bounties that we actually put out for Gitcoin's batch number 10 hackathon. And I've actually gone ahead and opened up the links for them. So yeah, there's 8 of them, and I'm just going to briefly walk through them and give our esteemed audience an opportunity to ask any questions. So just quickly before we start, we are advertising all the prizes in USDC. We do reserve the right to pay them out in Bluzelle. We probably will pay them out in USDC, but if we pay it out in Bluzelle, it'll always be at the current market prices at the time of payout. So if you're a participant, don't worry. The prize we're listing here is exactly what you will get. Yeah. So the first hackathon bounty we have here is the AMM module, and AMM stands for Auto Market Maker. If you've used Balancer or Pancake Swap or Sushi Swap or Uniswap, you'll be familiar with AMM. So the idea here is we want to bring a module into our Bluzelle chain. And the idea is you would fork our chain and add an AMM module. Now, there are AMM modules available out there that you could probably bring off the shelf with some modifications. And you would add a proof of concept, a front end, so that people could do the fundamentals like add liquidity, remove liquidity, and obviously swap tokens. This kind of leads a little bit into some of the IBC stuff we're going to talk about, but the idea here is really for the proof of concept, we want to see that you have multiple tokens on your chain and you have an AMM module that allows people to add liquidity and obviously do swaps. So I'm going to kind of leave it at that. Most of the information is here in the descriptions. Do you guys have any questions?
Yeah, so I guess the main idea of this hack is to, from what I understand, if it's similar to PancakeSwap or Uniswap, to set up pools within the Bluzelle chain and also have atomic swaps within those pools, right? So I guess the objective here is to see multiple tokens being swapped around within the chain. Is that correct?
Yeah, the longer term plan for Bluzelle is for us to be onboarded with IBC, the Inter-Blockchain Communication Protocol. And that's going to mean we're not just going to have the Bluzelle token, but potentially any Cosmos token. In fact, there's going to be an ERC20 bridge to Ethereum. So, you could see ERC20 tokens and even ETH on the Bluzelle chain. So yeah, it's going to become a very high speed, low cost way to do crypto exchange without, worrying about, obviously the current costs that you deal with if you're on Uniswap or, any sort of Ethereum based chain.
Yeah, that's excellent because, there are scenarios where it's like you're trying to, do liquidity staking or things like that. And then the fees just get you when you, reap your rewards,
Yeah.
right? So that's great to hear.
Real pain point with Ethereum right now, unfortunately.
Absolutely.
Okay. The next bot and these the next hackathon bounty here, and these are not in any particular order, by the way, is our Discord Blizzellbot. This is a simpler one. I termed it intermediate, $2,500, and what we want is a bot that can run on Discord, connect to our channels. We have a very active Discord community, and report to our Discord channel statistics from our networks, whether it's our test nets or our mainnet. So instead of having to go to Big Dipper, as Matthew had shown you just now, you'll be able to see your stats right in Discord. It'll show you whatever. I mean, we're leaving this pretty open. Maybe it's graphs, maybe it's text, we don't know. But that's the idea. So, I think it's a reasonably straightforward hack here. And of course, we'll help you out if you need to implement this in our Discord channel, whatever you need. But that's the idea. And there's already lots of bots on Discord already. So there should be, APIs and documentation on how to do this. Any questions on this one?
I think it's pretty straightforward.
No?
Yeah.
Straightforward. Yeah, okay. The next one is IBC, which I just mentioned kind of with the AMM. So inter-blockchain communication. This one's definitely advanced. It's going to require someone to likely fork our Stargate Curium network and create your own testnet. You create your own network, and the idea is you're going to implement IBC, which, again, shouldn't be terribly difficult with Stargate because it's actually one of the features of Stargate. But what we'd like to see as part of this proof of concept is you can move tokens in and out of Bluzelle. You can potentially run services, run transactions that actually run across chains. So it's a pretty big departure from what we've been doing, where so far we're just operating on one chain. This is now interchain. So it's we're paying 5,000 USDC for it. It's a pretty large project. There's definitely precedent. There's companies out there on the Cosmos community that are doing it, IBC. It's not new. But definitely, this is a big part of our future roadmap, and consequently, yeah, we want to have a hack for this. And as I said, this could potentially tie into the AMM. I don't believe the AMM depends on this, but once we go into production, this is something we'd want. Any questions from anyone?
Yeah, I have one specifically for this. So so from my understanding, and this is a great hack, by the way, because there are chains out there that have kind of like a bridging utility to get assets from one chain over to the other. So IBC lets you do that. So for this hack specifically, is the ask kind of just to provide a proof of concept of having, the fork Stargate Bluzelle chain running IBC, and then also another chain, and then kind of using IBC to transfer between those two chains? Is that
Yeah. There's various ways to skin this cat.
Okay.
So one of them is you could actually run your own 2 test nets, and you could just demonstrate that there's IBC between the two, and you could have your 2 test nets in your own silo. I mean, you can run them in your own lab, whatever. So that might be an easier option. One of the other options is you could choose to do this against a test net, an existing test net out there. I mean, heck, you could just build your own private chain at home on your office and run it against our testnet, our testnet private for the hackathon. I mean, that's perfectly fine. I mean, you could show that the Bluzelle token moves between our hackathon testnet and your own private testnet. Sure.
Perfect.
So that's the idea. Yeah, it's a good question.
Thank you.
Yep. The next one, I love this one just because I love programming languages. So this is kind of a special hackathon bounty. We actually have there's kind of several sub bounties. So what do we want to have? And Avon kind of touched upon this earlier, and even Matthew to some extent, is, they were using the JavaScript, TypeScript libraries, but really we want to have libraries in all these other languages. And in fact, we're open to languages that are unlisted here. We kind of gave a suggestion of the top libraries we're interested in. So what we'd like to see is submissions where you literally have built a library using, that supports these languages. Now, with Stargate, which is what we're currently using, you've got a lot of help. You got these proto files, which we'll be providing you to. We'll be actually updating this this hackathon description with the proto files. So once you have those proto files, you can actually use protobuf's compilers to build most of what you need to support these languages. There is a little piece that you need to build, which is the transport module, which is something you got to build by hand. And we've documented this here. And obviously, if you know protobuf, you can build that out. So yeah, we're paying $2,500 per each library. And I would highly recommend, if you want to build in a library that's not listed here, just reach out to us on Discord and just give us a heads up. We're pretty open to it. I mean, if somebody came to me and said they want to build a COBOL library, I'd be down with that. That's fine. Any questions?
Yeah, so is the goal for these libraries to kind of be on par with the current JS/TypeScript library, maybe some more on top of it, but definitely like bare minimum?
They're supposed to be kind of siblings. The idea is, I mean, the current JavaScript libraries are built off of our proto files, right? So that's kind of our first programming language release, right? But these are not built on top of JavaScript. They're supposed to use the same sources, right? The proto files.
Right.
And what we're trying to do here is really have everything so it's kind of automated. And that's a really great question, even, because the idea here is, as we add more and more stuff to the spec, let's say we add a new function to our libraries, they're actually going to go on the proto files. And if you did your job right, you can recompile the proto files, and effectively you would get new versions of these libraries automatically. That's in theory, right? You don't have to rewrite the transport layer. That's not going to change, but you'll get automatically new versions of all these libraries. So that's really the beauty of this new design. And that's part of why we're asking for this. We want programming language support. We have a lot of developers that use these languages, and yeah, we want to support them. Any questions? Any other questions? Okay. The next one's a more of an advanced project. This is also actually really cool. EVM OCW. OCW stands for off-chain worker. It's a term that we kind of stole from the Polkadot guys. We'll get to that in a moment, the palette. And the idea here is to build some sort of listener or bridge that would allow EVM or Ethereum smart contracts to talk to Bluzelle. Now, that typically would be, accessing our oracles or reading values from our database and getting those values back. So the flow really is a smart contract posts a request, they got to pay for it in gas. And we'll get to this in a moment, but they got to pay enough in gas. And there's a really important reason for that. So they make the request. They might say, I don't know, give me the price of Bluzelle USDT, right? And that request goes out over the off-chain worker. And the off-chain worker actually kind of sits there as a bridge. It listens to requests from the EVM, the smart contract, and it goes out to Bluzelle, asks the question, hey, give me the value. Bluzelle comes back, and then the off-chain worker actually has to post a transaction back into the Ethereum virtual machine, whether it's Ethereum itself or Binance Smart Chain or what have you. So the reason I emphasize that the gas has to be paid sufficiently is the off-chain worker is only going to pay enough gas to cover what was paid for with the original transaction. Now, for some reason, if that original request by the smart contract was not sufficient, the off-chain worker is probably going to create a transaction that will fail. It'll run out of gas. And it's really simple. You wasted your gas making the request. So yeah, spend enough. So that's basically the idea. It's a bridge to read from Bluzelle. As a bonus, we'd love to see if you can write to Bluzelle. We're not really emphasizing it because that would require you to have gas to write to Bluzelle as well. And that's a whole other ball of wax that we haven't really gotten into. But hey, you know what? If you can pull that off, fantastic. Any questions from anyone on this one?
Yeah, so I have one. So basically, just to confirm my understanding, so you kind of initiate on the EVM-based chain, whether that's Ethereum or whatever it might be, and you're kind of communicating to a smart contract. Now, there, you know, from my understanding, there's no way to have that smart contract call out to an off-chain worker directly, so that off-chain worker will probably need to read the smart contract data for that request, and then the off-chain worker would then talk to the Bluzelle oracles to get, you know, in your example, to get the price of, you know, USDC or whatever it may be, the price of the pairings, and then post it back to, say, that smart contract on the EVM chain. So then you get that off-chain data via the off-chain worker. Is that correct?
Yeah, and it's not, Matthew, it's not limited to just oracles. It could be even a database.
Yeah,
I mean, you could go in anything. I mean, you know, we're actually kind of looking for the purposes of this hack, we're really looking for CRUD support for a database, but because we don't have oracles currently supported in our main testnet, we did provide instructions if you really wanted to support that, because our other testnet does support it. But yes, that is the idea. The off-chain worker would effectively listen for events emitted by a smart contract from the originator and go off, get the answer, and then submit them back.
Cool.
Yeah.
Great.
Okay.
Thank you.
Thank you. So the next one is, it's actually really similar to the previous one. This is kind of off-chain worker specifically for Polkadot. So we're really interested in Polkadot. We're working with them pretty closely. This is an advanced project, and hence we're paying this much. And the idea is you build something called a pallet, which is really, in a way, it's an off-chain worker kind of all wrapped together in one in the Polkadot world. And the idea is the pallet would be something you could drop into your Polkadot dApp, and you could then make requests to Bluzelle. It's very similar to what we just discussed. They call it a pallet in the Polkadot world, and the pallet actually also has an off-chain worker, which is actually compiled into the pallet. And it effectively does exactly what we just discussed. So we won't really go over that again. Typically, I believe these pallets would be written in Rust. I do not know if that's possible to do in another programming language. The Polkadot world uses something called Substrate, which I believe is typically in Rust, but there may be other ways to write it. So that's really what it comes down to. I obviously have oversimplified this greatly, but there's a wide wealth of information on Polkadot out there. Any questions on this one?
Yeah, so I guess from my understanding and from what you've just mentioned, you know, it's mainly Rust that you'd be writing this in, but it's not limited in terms of this hack. If you wanted to write it something else and it supports that language, we could do that. Is that correct?
Sure, write it in Visual Basic.
Maybe not that far, but I guess.
Yeah.
I
Yeah,
suppose so.
Yeah. We're, for the purposes of the hackathon, we are looking for architecture in proper style, but I mean, if you can execute in another language, I mean, that's fine.
Okay.
We're just giving guidelines.
Perfect.
Blockchain inbox is a nice one. The problem statement here, this is a bit of a consumer application. It's an intermediate. The problem statement here is, I need to contact someone. I don't know their name. I don't know their email address. All I know is their blockchain address. It could be a Bitcoin address. It could be Ethereum. It could be Polkadot. It could be Neo. It could be Bluzelle. How do I contact them? I can't. There's no place to send a message to someone. You could send tokens to someone. You can do lots of stuff, but you can't really send a message, a text message to someone. So this solves that problem. The idea here is it's an inbox. You can go in and you can send a text message to any blockchain address you want across any chain. All you need to know is their blockchain address. This is, it's kind of a lazy creation type of project. And what I mean by that is the person receiving the message doesn't actually have to have already gone in and registered. So if I'm, say, sending a message to address XYZ, and that happens to belong to Matthew, he doesn't have to have already gone in and created an inbox on this service in order for me to send a message. I can send him the message, and if and when he logs in, he will see the message. It'll be sitting there waiting for him. It's kind of like how PayPal was back in the early days. You could send money to someone without the recipient actually being a PayPal user. So same idea, blockchain agnostic. One of the key things that we really want to see here is that the messages are kept private. And what that means is that the message I send to, say, Matthew is encrypted with his public key. And that ensures that not only can I contact him, but only he can read it. We don't want a situation where, people are sending off messages to people and then, third parties can read them, because obviously this is all going to be stored on the Bluzelle chain. Privacy is still an important thing. So we just want to default things to being signed, encrypted with the person's private key so that only the intended recipient can even read it. Yeah. Any questions on this one?
Not really a question, more of a comment, but I think this is a pretty great hack, to be honest, because, there are instances where, I'm just thinking of this in a real world scenario kind of thing where I, mistakenly sent funds over to an address, right? And I wanted to reach out to them and tell them, hey, at least to check and see if they would return it or whatever it might be. But at least I can communicate to that person, right? Who owns that address or entity. Yes, there are, things like you can attach metadata to a transaction, but it's not always, the simplest way. Like, those who don't know how to attach metadata to a transaction probably won't have an idea. But, if you use Bluzelle, and we've seen it in the demos that it's very easy to perform CRUD functionality and attach that to an inbox idea. So I think this is a pretty great hack, and it has
and further to what you're saying, not every chain allows metadata, right?
Exactly.
There may be existing chains, there are existing chains, and there probably are going to be future chains that don't allow that, and it's very fragmented. So we're trying to create a kind of decentralized yet private, anonymous one-stop shop for inbox for any blockchain address.
Yeah, for sure.
Because if the future really is about crypto, it would be very useful to be able to contact people anonymously and for them to respond to you anonymously. And that's what the inbox is here.
Yeah.
So great question.
Yeah.
Our last hackathon bounty is our censor-resistant web hosting services. So this is intermediate. The idea here is pretty much self-explanatory, but we want to become a platform where any website, typically static, because we're not going to support or we're not asking for server-side, execution, PHP or Python or whatever, hosting. So the idea here is you have a website, you want to host it, you want to make sure it's going to be available tomorrow. You want to make sure, your host, whoever that might be, one of the big cloud providers, doesn't shut you down. Maybe they don't like you. Maybe your name is Donald Trump, whatever. We're not saying we support Donald Trump, but the idea here is we want to finally provide a way for websites to be hosted without any disruption. So the idea then is you would use these censor-resistant web hosting services, almost like Git, and you could push and pull content, and you could store CSS, HTML, whatever you want, images, whatever. Your entire website is stored on Bluzelle. And there's an endpoint, which is the service endpoint you're building that's part of the hack. And that service endpoint is to act like a web server, right? It receives requests. It can look at the HTTP 2.0 or 1.1 header. It can figure out the DNS request, right? Because you're pointing your DNS here. And it can then grab the right content and literally render back a web page. So from the web browser user standpoint, they're just going to a regular website. Yet behind the scenes, it's coming out of Bluzelle. The entire thing is driven by our decentralized database. And of course, one of the great things about this is provenance. You as the website owner have complete authority and domain over your website. Nobody can take it down except you, even we can't. And of course, that means you're there, you're always there. So, we're big proponents of, non-censorship, making sure that, information can be disseminated without any interruption. And this is really critical. So yeah, really looking forward to seeing something in here. Any questions on this one?
Mostly about file size limits. So, with a static hosting, if I was putting up a website, just a bunch of static files and stuff, I would normally have concerns about storage space, things like that, or, picking out the best plans or whatever on static hosting. Where would I find, the limitations in doing that with Bluzelle, or what are the limits?
Yeah, for the time being, for the purpose of the hackathon, just we're kind of sticking loosely to a limitation of 250 kilobytes.
Okay.
It's not huge. The reality is you can probably go a lot larger. We actually already support NFT on our chain. We didn't discuss it for the purposes of the hackathon, but we can support up to 100 megabytes. We don't really openly advertise it. And frankly, the purpose of this particular hack isn't to turn Bluzelle into YouTube or Google Docs or Google Drive. It's really to allow you to host a website. If you have a 100 megabyte or 1,000 megabyte or 1 gigabyte video file that you really want to show, the recommendation here is stored on Google Drive, and maybe just create like a shim web page on here. You can still use the service, and it would point to it, right? It would maybe have a little iframe or something to show the video, but the actual video itself wouldn't be showed here. Frankly, it's not economical to store a massive file on a decentralized network. It doesn't make an economic sense. That might change in the future, but right now, this is really about hosting web services.
Perfect. Thank you.
Yeah, great. So yeah, that's kind of it, folks. Thanks for sticking around. I know it's been a long workshop, but thank you, Avin and Matthew and Harjot for your feedback, and obviously for your demos. And we're going to be the entire Bluzelle team. We're super excited. We want to see what you guys are submitting. We've already seen some people have applied, as you can see here, and we're sure there's going to be tons of questions and suggestions coming out. We're on Discord, we're monitoring it, and we're there to support you. And I might have said it at the beginning of this workshop, some of these projects are pretty big. they're going to take time. And we recognize that some of them may take longer than the span of the actual hackathon. So we are open to, even though, some of these, it says 19 days here, we are open to projects that are going over, especially the more harder ones. And we'll definitely be there to support you. And, we'll obviously make an informed decision on when to choose the winners. But yeah, we just wanted to put that out there. The other thing I wanted to mention is it's kind of documented here, and don't really want to go into too much detail about it, but please document and test your work. We don't have the bandwidth to test your stuff very much. We don't have the bandwidth to go back and forth if there's bugs. It is critical to make sure that what you build works. We have a very limited window, and we're going to follow your documentation, and we're going to judge your project based on the quality of your documentation and, of course, how your code is reflected upon. So the ideal, obviously, is we follow your documentation to a T and everything works. That's the happy path. We'd love to see that. And if you follow that happy path, that improves your chances of winning. So definitely observe that. I can't stress enough writing good documentation and just testing your documentation, making sure that what you submit to us is going to work when we try it out. Okay. And that is about it.